Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. Today I think we really just have to fuss a little bit with our, we built sort of a customized multi-sample buffer resolution scheme last weekend, but we only just got everything finished up. I guess we did it on Sunday, we tried this. We only got everything finished up by the end of the stream. We didn't have a chance to actually play with algorithms for doing what we were trying to do. We only had time to get all the pipelines set up for doing it and that kind of thing. So today, I think the only thing we really want to do is try to figure out if there's some kind of custom resolution scheme we can use to make that work. It's an almond milk day today. Yeah. This is going to be one where it would be nice to have drawing, so I may just try to draw without the cursor. It could be fun. Who knows? We'll see. Anyway, let's go ahead and get started here. So let me show you where we were at last time. I believe we left it so that we were booting into the multi-sample resolution version of the game, because there's a hint you can toggle on and off. Oops, I don't need to do that again. I meant MS-Dev. But we aren't really doing it right yet. Or right's the wrong term here, because we don't actually know what algorithm we would use. All we know is that we might be able to do better than the default. So I believe this is our custom multi-resolution resolve here that's happening. And what you can see is if I turn it off, so this is I'm not going to turn off the custom one, I'm just going to turn off multi-sampling, right? So if you notice, when I turn off multi-sampling, right, we've done a really good job, I think, at this point, render-wise, because everything is looking really good, and I'm really happy with what we did, I think it's ready to put the art in there. Happy with all of that. So the only thing that I thought was really objectionable was these sort of jagged lines on the geometric primitives for the ground, right? And like I said, even though we're going to be texture mapping stuff onto that ground, those hard edges, I think, would still remain. Because you can imagine you put a texture on this or other stuff, you'd still see those hard edges. Now, there's some ground cover stamping sort of stuff that we're probably going to be doing. And so I feel like, maybe that would hide these edges. So it might be that we're, going a little bit too far in terms of trying to improve the visual quality. But I don't know. I want to at least have some confidence that, let's say this was a dungeon area and this was some kind of a stone tile. Well, there's not going to be any fringing of that. It's just going to be a hard edge on that tile, and I feel like that's going to cause problems if we don't have a way to smooth that out. If we just want really high fidelity, or high quality rather, on the graphics there. So we can turn on multi-sampling, and what that will do is that'll sort of help smooth out all those edges, and that's nice. But the problem that we get with that is that the resolve, the multi-sample resolve, leads to poor results with the depth peeling. And this is somewhat understandable because depth peeling is requiring, the whole concept of depth peeling is assuming that you have one pixel per depth sample, one color value for the pixel, one depth sample for the pixel. And so when you move to a multi-sampling scheme, the problem is that you end up having more than one, right? You end up having multiple color and depth samples per pixel. And in order to move to the next step in the scheme, for depth peeling, we've got each peel. In order to move to the next step in the scheme, you need only one. You need to have some understanding of what the particular sample was. And furthermore, there's not really a way to do this with, well, I shouldn't say there's not a way to do it. If we wanted to just persist the multi-sampling through the entire scheme, we end up in sort of an unfortunate position. And the reason that we end up in an unfortunate position is that the whole point of multisampling versus just oversampling is that you only pay for the oversampling at the edges of things. So the whole point of using multisampling is that on cards that do it smartly, you will not be paying for oversampling in here, for example. Because since one geometric primitive is covering this whole thing, you will not pay for oversampling here. You might right along this diagonal, because this diagonal there's two primitives right there, right? One triangle, that form the quad. But inside the triangle, you will not pay for multisampling because the triangle covers the entire pixel. So it runs as fast as it would, more or less, than if you weren't multisampling. And so that's an important speed win, especially on modern hardware. This piece of hardware is nuts. It's from a decade ago, so it's not a particularly good test case, but just in general, I think what we would find, unless I'm very much in error, we would have to test it, but my assumption certainly is that what we would find if we went through and tested the two types of methodologies is that multisampling would be significantly faster than oversampling. And oversampling would just be if we rendered at a much higher resolution than we were planning to use. Say, we were planning to use 1920 by 1080, and we just render at 2 or 3 times that resolution in both dimensions, and then downsampled. And that has the benefit of just working correctly with depth peeling, because you're now just one depth sample per pixel still all the time until you finally smush everything down. The whole pipeline runs in a higher resolution. It runs in 4K or something, right? And then downsamples. But again, that will just literally be at least, if not worse, n times slower, where n is the number of pixels that there are, and where n is the multiplier on how many pixels there are. So if we were to double the resolution in x and y, for example, which would just be 2x in either direction, that's 4x more pixels, so it would be 4 times slower to run in that. And at least theoretically, the multisampling version will not be 4 times slower. It will be a little slower, but not that much. Because it's not, most of the slowness does not come for doing more pixels, because it's actually not doing that many more samples, especially because our primitives are very large in Handmade Hero, so there's not a lot of edges on them. But the point here is basically that, when we are doing the main bulk of those things, although we are not going to pay for the more pixels, we are going to pay for the more memory bandwidth, because the multisample buffer is larger than a non-multisample buffer. So we will be paying a cache and memory bandwidth cost one way or the other, so it will get a little slower. It's not free, but it's not 100% the cost of oversampling. In fact, it's probably not even close. So I do think we want to at least try to get multisampling working instead of just going for something like oversampling, which would be quite a bit more expensive, but work properly with the scheme. So what we tried to do to ameliorate some of the problems here that we see with the multisampling, specifically like up in the trees. I don't know if you can kind of see what's going on there. Let's say I move over here, so you can see it move a bit, but you can see a lot of kind of like, it's not really traditional Z fighting, but it's like, I think, a form of Z fighting, right, where the depth buffer itself, go ahead and make a place where we can zoom in and out. Where the depth buffer itself during that sort of resolution from multisample to non is like picking, values that exhibit this problem, that sort of fight back and forth about who's the closer pixel. And so you end up, what we want to do is pick something reasonable when we do our resolve and not have that kind of problem occur. And again, because everything else is looking pretty good, I'm not seeing a lot of artifacts in anywhere else. So, when you do the multisampling, it looks like we would just pretty much have what we wanted if we could just figure out a way to stop that sort of nasty effect from happening with the resolve. So we have the custom resolve working here, right? Here's the custom resolve right here that I'm on. And if you take a look at this custom resolve, what we have is we've got the color buffer and the depth buffer. Oh, and you know what? Before I forget, let me do one thing that people were asking for. Apparently, because we switched to using sampler MS, multi-sample, right? Sampler 2D MS, because we need that to do the custom resolve. And the multi-sample, the custom resolve functions are only available in shader 150. So really, we kind of need to specify that version when we do the multi-sampling. Now, we only need it for that shader. So thankfully, we can still, if you run with multi-sampling turned off, you could still run in version 130 if your card only supported 130, right? So that's kind of nice. Now, the graphics card should have complained about that, but I guess this graphics card's compiler doesn't really check that. It didn't have error checking for that, so since the card happens to know 2D sampler 2D MS, it just worked even though we had version 130. It's not supposed to, but it did. Other people who compiled on more stringent cards, probably on an NVIDIA driver or something, got that error, so they just let me know. So hopefully that'll help them make sure that that compiles properly on their machines. The shader compiler, not the regular compile step, obviously. So you can kind of see here what we're doing. Our resolve loops over the sample count. We look up the various samples for this, we're looking at the same pixel. We look up each sample. We look up the depth sample and the color sample. And then we need to output something. So what we're doing right now is just a straight up average. A straight up pick of whatever the closest depth value was, right? And the problem with that is when we pick the closest depth value, what we're essentially doing, and let me see if I can, I'm just gonna try. I know it's a bad idea. I'm just gonna try to do a drawing without really having a drawing program, a functioning drawing program. I'm gonna try it because you only live once. You know what I'm saying? All right, so let's go ahead and load. Okay. So here's me doing an offset drawing. Let's see here. So what day is today? Today is day 387. So day, whoa, now it's on? Oh, that's because it lost connection. I tell you, like, we just really need to go into Milton and fix whatever the bugs are here. Like, you can see that when it loses focus, like when my program, when this happens, it appears to lose focus, right? And you can see that now it's locked on properly, and I think that's because now it's not getting tablet input, it's getting like mouse input or something, right? And then when I relaunch it, you can see, when I relaunch it, it's back again, right? The pressure sensitivity has returned, it's getting tablet input, but now the offset is back, right? It's very strange. And so I know that's fixable, I just don't know what the problem actually is. All right, so this is gonna be some of the worst writing you've ever seen from me, and that's saying something. Oops. There we go. All right. So the problem here that we're experiencing is we have inside our pixel, we've got a few sample points, right? I think in our case we actually have 8. So there's quite a few of these bad boys in there, right? That's 8 right there. 1, 2, 3, 4, 5, 6, 7, 8. So at each of these samples, we have a color and a depth value, right? Now remember, In cases where a pixel was entirely covered by a single primitive, we effectively only have one sample, because all 8 samples in the multi-sample buffer will have the same depth and the same color. So in that case, it's trivial, because pretty much whatever scheme we pick will produce the right answer, which is just that answer, right? So the case that we're concerned about is the case where these 8 samples have different values. Now, some of them may have the same value, and some of them may have different values, and we have to figure out what to do about this. So I think the problem that we're seeing is, for example, in our trees. We've got a situation where, remember, we have the z-bias program happening. And what the z-bias program does is, as we go up the drawing, the z, even though it's a flat sprite card that's camera aligned, so the z relative to the camera should be the same the whole way, we don't use it the same the whole way. What we actually do is we artificially boost the z value, make it closer to the camera, which in this case I guess is actually making it less, right? Because if you remember, our convention for z here is that the lower depth is closer to the camera. So we actually subtract from the z value and make it get closer, right? And so what that means is that down at the bottom, right, in here, we're starting off at a certain z value and ending at another z value in here. There's like those shadows that are down at the bottom here, right? The tree shadow. Those shadow pixels, therefore, are all at different z values. What that means is that where we hit the edge, now, I just want to be totally clear on this. Just want to say one more time. Multi-sampling, when you're inside a primitive, just writes all the samples normally, if there isn't some reason for it not to. So I just want to be clear, inside the primitive, in here, there is no problem. Or you know, where I drew it right here, for example, no problem. It's only on the edge. And the reason that the edge is the problem is because where the edge of the primitive is, that's where multisampling kicks in. Because remember, the point of multisampling is to smooth primitive edges, right? So at the edges, what happens is we're going to write all of these samples. And some of them, right, will go to something else, and some of them won't, right? So some of them will go to our primitive, some of them will go to something else. The problem I believe we're having, and we did some work to verify this last weekend, so I'm fairly confident in it, although we haven't proven it beyond the shadow of a doubt, pun intended, is that these samples here, when they're written at the edge for the tree sprite, they're all going to get a different z value, right? Because remember, our z shader is now operating, our z bias shader is now operating per sample. So the z value of each of these is going to be slightly different. So I think what happens is, when it goes to do the depth peeling, it goes, oh, okay, well, what's the closest one? Well, the closest one obviously is going to be the highest one up, right? It's going to be that one. So it's like, oh, okay, I found it. That's the closest one. Put that into the depth peel buffer. Then the next round of depth peeling, it goes, well, what's the closest one now? Well, the closest one now is now a multi-sample from the same primitive. So instead of peeling away the primitive, what we actually did is just gather multiple samples from the same primitive. Since we're at 8x oversampling and we're only depth peeling away 4 layers, we basically just end up in a situation where all of our depth peels record the same damn primitive, right? And that's just not helpful, because what we want to do is we want to peel away primitives. So what we need to do is try to come up with some metric that inside a pixel will discard values from the same primitive. Unfortunately, I don't really know any way to do this directly, right? What I want to do is, say, write all of the samples with the exact same z and color value if you're coming from this same sample, right? From the same primitive. And I just don't know how to do that, right? In other words, what I want it to do is I want it to just, I want it to write the same value for the z that it would write for the entire pixel. And because there is no way that I can find to do that, like I was unable to find any way to force it to always write the same z value for all the same. I just generate, like don't interpolate z per sample. That's all I wanted, right? I just want it to not interpolate z per sample. And this would be, I think, fairly easy for it to do. It's not available, right? And barring that, if it wasn't going to write z per sample, then just, well, okay, here's a question for you. Because I thought we tried this. Didn't last weekend, I remember us trying this, where we wrote, we overrode what the sample z was, right? We passed down a sample z, and we said, all right, here's the z that you're going to use. And that way it wouldn't take multiple samples for it. I thought that's what we did. And I guess, now I'm thinking about it, I can't remember us having any luck with that. And I feel like there should have been a way to do that, but I guess now that I think about it, other than relying on Centroid and stuff like that, I guess there's no real way to force flood all the samples. Yeah, I just don't know. So it leaves us in the unenviable position. I mean, that's what we want. And I feel like if we were in, I feel like there must be some way to do that. I want to pull a graphics, one of those saucy graphics gentlemen aside and just ask, because I'm sure they would know. I don't know. And just be like, hey, all I want to do is I want to make sure that all of the z values generated from a single invocation of the fragment shader always have the exact same sample value, z values of the samples. Because that's all we wanted, right? I don't even care the color values could be different. I don't even care about that. I just need the z values to be the same so that the depth peeling will work. But yeah. All right, so what we need to do here, let's just try this technique anyway, even though really what I want is not this. But if I recall correctly, we tried to make that, to convince the graphics card to do that, and it wouldn't do it. So if we look here, and we're going to do this texel fetch to grab out our depth values, what I want to do here is say, well, okay, we're averaging the colors together for this. And really, I don't know that that's what we wanted to do, because this is excuse me, picking a single depth value but averaging the colors, which doesn't make a whole lot of sense. So that probably should get fixed. But what we want to do here is let's say that we just want to pick a representative sample. So what I want to do for picking a representative sample, I think, is I want to pick a sample that's going to be the furthest back sample of the close samples, right? And this is kind of a weird thing to say. But what I'm assuming, right, is that what I have here is I've got two primitives, and let's say I'm looking from the top down here. So the camera's up here, and I'm looking down. And I've got two primitives, right, like this. Now, the problem is, because, again, of the z-bias in this case, but we would have this problem if we had other primitives, and we do sort of have other primitives, like the sides of the cubes. The problem here is that they're sort of on an angle, right? They're slanted like that. So I'm looking down at these two, and effectively my pixel, right, is sort of talking about picking out sort of a shaft, you know, along the camera direction. Now, mind you, it's not parallel because this is actually a perspective projection. So technically, actually, it's, you know, this is a really hard to do drawing without having a cursor. Okay, there we go. It's really more like that, right? Because as you get further away, the sort of range encompassed by a pixel is getting larger, certainly. But what you can see here is that, you know, I've got samples from this guy, and then I've got samples from this guy. Now, if you think about what that means, it means that if we had some way of figuring out, right? Because remember, I just want to split the primitives. I just want to do that. If we had some way of figuring out which were from which, we would be okay. For depth peeling purposes, what I want to do is pick the furthest one back, right? Okay, so where am I? I'm right here. So what I want to do is I want to pick like right there, right? So if I had a sample that was at the edge of that, that's what I want to pick, because I know that when I depth peel again the next time, now I will only get samples from this further away thing. I won't accidentally pick more samples from this primitive up here that I was basically trying to remove, right? So yeah, so that's just that. Now, you know, one thing we could imagine doing, and the reason that I'm not doing this is just because, again, it's much too costly, I think. But you could imagine an easy way to solve this problem would be to just have another buffer, right? And the other buffer just stores the primitive index. That'd be it. Because then all I would do is, as I step through these, I'd go, oh, what primitive are we on? Okay, you know, if take the furthest back sample that's from the same primitive index as me, right? And that's easy. But we don't really have that. So what I'm going to try to do instead is say, well, maybe I can build like a little mini cluster here of depth samples. And so basically say, if the depth sample is further back, but not too much further back, then we'll use it. If it is too much further back, we will assume that it's from a separate primitive. Right? This isn't going to work perfectly, right? Because as you get two things that are at the exact same z, it will fail. But you know, again, we're just trying to minimize the artifacts here, so maybe this will be good. It's frustrating to not be able to have the graphics card do the sort of relatively simple thing that would solve this problem, but that's graphics cards for you. And maybe if we ask, like I said, a graphics person if there would be some way to do it, we could say, for multisampling, require a much higher shader mode and a much better graphics card, and then only enable multisampling on those cards. Because again, multisampling is like a feature that is a higher end graphics feature for our game. It's not required. You can just have those sort of polygonal edges and the game will work just fine. It just doesn't quite look as good. And so that's just, you know, that's just the trade-off there. So if I was going to do that, what I need to do here is say, like, okay, here's the vertex code, fragment code for it. I don't need to change anything in the vertex code because I'm not, again, this is just drawing a full screen quad. So all I'm going to do is just change this rule here. So what you can see is I'm going over each sample, I'm getting the color, I'm getting the depth. So what I want to do now is say, well, okay, let's defer picking the color here till maybe after this, right? And what I want to do is say, okay, and you know, and I could even defer the whole thing, right? I can defer this whole thing. So let's take a look here and say, all right, I'm going to grab the depth, and what I want to do is I want to take the depth and go from a closest depth scheme to a furthest depth scheme, right? So I'm going to start off by saying the furthest depth rather is the one that's right at the camera, right? That nobody could have. So everything's at first going to pass. So what I'm going to do is I'm going to take a look at the depth, right? And actually, I suppose what I should do is say, let's start with sample index 1. And you know what I could do is just say, let's just get that depth in here to begin with. So what we're going to do, right, is we're just going to say, let's get the color. Let's get the color, let's get the depth. So we start off here with a valid color and depth, right? And you know, since depth isn't used anywhere, I'm just going to call this depth. I don't think we need to be more specific. So I'm going to say that we just have color and depth here. Here we go. Oops. And so that just selects the very first sample and uses that as the seed value. So we start on whatever the first sample happens to be. We're on that depth, and off we go. So now we come through the rest of our samples. We fetch the depth value of whatever sample we're on. And now what I want to say is, well, if this depth value is further away, or if it's closer, I'm going to take different actions. So let's suppose that this depth that we get back is, and you know what, since I don't really care about averaging colors at this point, I may actually move this all the way to the end, right? I may say something like, let's get rid of all this. And just say that we'll pick a result color and we'll have a depth, right? And if we just are picking one color, what you can see here is that we will be squaring the color and then square rooting it immediately. So we wouldn't need to do that. So because again, the only reason we need to do gamma correction is if we're going to operate on the colors. If we just pick a color rather than combining them, which I think is fine, because again, all we're trying to do here with multisampling, well, you know what? No, that's not true. Because since we have polygon edges, I guess we do need that. Never mind, I take it back. We do need to actually average them. We can't just pick. So what we could do here, let's see. What we could do here is say, all right, if we were going to treat the combined color after the fact, because I think that is sort of what we would have to do, I guess we could try to clear it in the meantime. Basically what we're trying to do is find sort of a depth range, if you will, that is the depth range that we're willing to accept for this particular pixel, where we'll average the color values together. Right? So I'm going to write this out in that unoptimized way first, and then we can always sort of do something smarter later on. So what I'm going to do here is say, here's our sample index, here's our sample count. We're going to loop through these. We're going to get these texels, right? Like so. So what I'm going to do is I'm going to say if the depth of a particular sample is greater than or equal to depth min and less than or equal to depth max, then we're going to accept it, right? We're going to fetch it. We're going to do the operation on it. So we're going to start out with 0. We're going to sum, like so. We're going to remember how many of these we did. So we add the color, we remember how many of those there were. Then at the end of that, we will do an inverse of the used sample count, and we'll multiply the combined color to get that, right? And then what I want to write here is I want to write the depth max. Again, this is different than what we were doing before. Rather than picking the closest, we're picking the furthest, but only the furthest within a range, so that we're trying to do that picking of primitives, right? So that's about it. Then we have to, again, square root. And again, in an sRGB mode, that would happen automatically. But right now, we're doing it ourselves. Okay. Because remember, we don't. Our art assets currently are not processed correctly, so they don't have the right thing working there. All right. So now what we need to do, we can get rid of combined color and depth up here, and we can just look at our depth loop itself. So we have a depth min and a depth max. And so what we want to do here is, I think, probably just initially seed the depth min and the depth max the same way, right? So we'll basically say, all right, let's fetch these. So we start out with the first sample, and we say, let's just assume that the depth range is whatever that sample says it is, right? Then we loop through the rest of our samples, we get whatever the depth value is for that particular sample, and we say, all right, if the depth, if the minimum depth value, and maybe I'll write this the opposite way around that I normally do just to be a little bit clearer. If the depth we get is less than the depth min, right? If it's closer to the camera, then what we want to do here is say, well, how much closer is it? If it's way closer, we need to reset our min and max, right? And I suppose that means we could just do this in one, well, okay. So here are our two cases, right? So we have depth min, depth max. Obviously, the depth can't be both, so I guess what we could do here is just do that and say, okay, so if you're closer than the minimum, we know you're a new sample that's in front of all our old samples. If you're further than the maximum, we know you're a new sample that's behind all of our samples. So all we really need to do is figure out what the correct action is to take here, right? Do we widen the range or do we reset the range? Hopefully that makes some sense. All right. So in the case where we're closer, right, what we know is that in that case, the depth min is always going to become the depth, right? Because we know that we are going to reset the range to be whatever the closest thing is. It's going to have to include that because we obviously want that close sample. But what we want to do here is see just how much the difference is, right? So there's a difference between these two, and we want to see how high it is. So we want to subtract depth min from depth to get a distance value. And then we want to see if that distance value is greater than the threshold. If it is, then we're going to set depth max as well, right? So if the difference value that we're tracking is greater than some modicum, right? And we don't know what that is. So we're going to set that probably up here, like pound define depth threshold 0.01f or something like this, right? So if the difference value crosses that depth threshold, then what we want to do is we want to set the depth max as well. So that's basically saying this sample was so much closer than the other samples that we're assuming there's a whole nother primitive in here. And let's move to tracking that primitive instead of the other primitive, right? And then similarly, if we have in here where we've got depth is greater than depth max, we want to do exactly the same thing. So the depth, the difference value here is, oops. It's that way around, right? Because depth in this case is the higher value. So what we want to do is say same thing. If the difference is greater than the depth threshold, then we wouldn't do anything, right? So I guess it's not quite the same thing. We really want the other way around. If we are within the threshold, then we expand the depth max, right? Now, this is a little bit wrong, okay? And the reason that it's a little bit wrong is because it produces sort of results that are based on the order in which the samples were taken. So we're going to do this way, but then I'm going to talk about that in a second. So don't let me forget. So now we've got to get this thing compiling. Unfortunately, I can't see it with real indentation, which is not the best thing. I don't know, maybe I can. Maybe if I paste it in here, I can. I need just like a CPP file. So here's that indented properly. Here's main. Looks like we're missing a closing. Looks like we're missing a closing one right here. Handy that indentation is, wouldn't you say? So now we got to debug that. We're going to have some compiler bugs in there, so let's go ahead and run that. Or compiler bugs, or not. So yeah, we can't really effectively step through this, so it's a little bit hard to tell. But you can see we've definitely not done a correct job because we're getting all sorts of weird artifacts there. So let's take a look at what's going on here and step through it and see if we can't figure out what's going on there. So here's our depth min, depth max. They're initialized at the start to the same value, right? So this way we have just the starting range. So then I'm going to pull a depth value out of the samples. I'm going to say if it was less than the minimum, then I want to see how much less than the minimum it was. So I'm going to take the difference between the minimum depth and it. Minimum depth is going to be like greater because it's a little bit further away. So when I do this subtract, I'm expecting a positive value here. So if it's greater than the depth threshold, then what I want to do is I want to move the whole range up to this point. So I'm going to set the depth max equal to depth. And in either case, I'm going to take the depth min and set it to depth, right? Because I always want to pick that. Okay. If that was not true, meaning that if instead of being in front of the min it was something else, check to see if it's greater than the max. If it is greater than the max, then what I want to do is take the difference there between, and again, depth is the higher value now because it's further away. And if that is less than the amount that we want to consider, then we're going to expand the range to include it. Okay. So then we come through, and now that we've produced a range, depth min to depth max, what we want to do is produce the color value. So we take the combined color and we assume that it starts at 0. We take the used sample count and assume it's at 0 as well because we have not accepted any samples yet. And then we then loop through all of our samples. We take the depth value. Okay, that's obviously wrong. We take the depth value at this particular sample, so that was a bug. That would cause the bug we saw, so that's good. That probably fixes that particular bug. If the depth value is in the range that we are allowing, we will fetch the color value out, right? We will then adjust for our RGB. We will sum that into our combined color that we're tracking, and we'll remember that we had one there. At that point, we will then grab the, after we've summed all those up, we will grab the maximum depth value, right? And that's going to be our fragment depth. We will then look at the inverse of the sample count. In fact, what we could do is write this here to make it a little clearer. So like there's our depth. Now we're going to write our color. So we're going to take the inverse sample count, which is just 1 over whatever, how many we used. And then we're going to take the result color and we're going to make that just be the adjusted combined color. So the combined color has n colors in it. We're just going to divide by n to produce the average. We then square root that to put it back into gamma space, and we write it out. So we fixed one bug there. Hopefully that bug was an important bug, and we'll see. So looking at this here, we're definitely doing something wrong. First of all, we still have the artifacts, or at least some of them. But we also aren't getting smoothing along our edges. So we must not really be allowing the range to be proper. So I want to check something here. I want to change this depth threshold to be like really big, right? So this should basically just sum everything. And I want to verify that it does. And so if you look there, it does look like that is sort of what's happening. Right? You can kind of see that we are now getting smoothing along our edges. So yeah. You know, I just had an interesting idea. I mean, granted, I don't know how interesting it is. But I wonder what would happen for depth peeling purposes if we just always took a particular depth sample. Meaning, if instead of trying to process the depth values, if we just took sample 0 of the depth. It wouldn't quite produce the right thing because sometimes that would be from a further away primitive. But since you've already averaged the color together, because you multisampled, it might work. Still not great. Gah. We really just want to be able to do the thing that I was talking about before, which is just take the average color of all the things that have the closest Z value and then the closest Z value, and we just want to force the original pixel shader, the fragment shader, for all the primitives to just write the same Z value for all of the samples that it writes in that pixel, right? That's really all we want it to do. But unfortunately, I just can't figure out a way to do that because that would be so perfect. That'd be exactly what we want. I think we would have no artifacts in that case. But in this case, we definitely have plenty of artifacts. So I really don't know what to do about that. I also don't know why this wouldn't have been a reasonable depth range. I'm a little confused about that. It seems like the depth values are not what I would expect them to be. Because, like, look at that. So I must have something wrong there, because that's a huge, like, remember, the depth values should only range between 0 and 1, right? I mean, we're pulling these values out of the depth buffer. They should only range between 0 and 1. So this is like 1/10 of the entire depth range. And yet, it doesn't seem to work. Maybe that's because of the non-linearity of the depth range. I'm not sure, but it is a bit weird, right? So really, if we took a look at how we wanted this to work, right? Really what we want to do is just track, the depth min. I'm going to delete this because I'm not really sure there's anything worth doing in here. So I'm going to say depth min is, really what we want to do is just this, right? I mean, we could do it like this. Right, all we want to do is just say, give us the minimum sample. That's going to be the one, and then when we come through here, we just do that. Right? I mean, that's what we really want. And that, I think, would just work. I must have messed something up there. But that, I think, would just work if we knew that we would always write the same values per pixel. Here we've got depth min. Let me just make sure I did this right. We go through all the samples. We say depth min. Oops. That's bad. There we go. So this just always takes the minimum sample, right? And then it averages everybody who was at that minimum depth sample. And the problem that we get with that, obviously, is that because we're still writing different z values per sample, we end up in a situation where those depth values are not all they're not all representative, right? They're not all giving that same minimum value. But I contend that's what we want, right? That's what we actually want to have happen. And so again, the problem that we see is that in here, right, where we're actually doing the work, this is the shader that's actually getting called multiple, per sample. What we want in this case is to be able to set our frag z in a way that won't vary per sample. And yeah, I just don't know how to convince it to do that. I think what we tried to do before is to say Centroid. And that was, supposedly something that would create that was supposedly something that would create a value that was going to be constant across the pixel, I think. We looked at the documentation on this and it wasn't as clear as I would have liked. But basically what we ended up doing is passing a different z in and overwriting it, right? So, I think it was actually frag depth that we wrote here, and and basically what we did is we said, okay, we're going to have an input z, and that input z is going to be something different, right? So the only real thing we needed, if I remember correctly, to do that, right, was we said, okay, we'd say, if we have a frag depth coming in from, if we have a z value that we want to use for all the fragments coming in from the vertex shader that we can force to not interpolate per sample, then what we'll do is we'll say, okay, the frag depth is going to be that, the frag z for comparison is going to be that as well, and then everything else just runs as normal, right? Because we can produce multiple colors, that's fine. We just want to, make sure that we only ever produce one z value for everything that we write for this primitive, whatever the primitive is, right? And so in order to make that work, we just needed a thing that was like Centroid, you know, in F32 input Z. And this just needed to output it. Right, that was it. And so we had to produce a Z value, and the Z value had to be, you know, transformed and all that good stuff. So whatever the Z value was that we were actually using, in this case, it was the modified Z, right? We'd take that modified Z, we'd have to make sure that we actually did our divide, right, just like it would do. And then we needed to put it into the range 0 to 1. So that was going to be a negative 1 to 1 range. But that's it, right? And so if I remember correctly, we tried that, and it didn't work, right? Cannot construct this type void. What does that mean? I guess it doesn't like... Is it just this that it doesn't like? Oh. No, I see what it's looking at. Somehow we got a semicolon in there. I mean a regular colon instead of a semicolon. Not sure how. So this is the version of that code, right, that's doing, in theory, writing the same Z value per pixel, right? Every sample inside a given pixel should have had the same one, I think. And again, the problem is, again, with any graphics card thing like this, it's very hard to figure out whether that's happening. Now, if we play with this a little bit more, because again, I'm just kind of shooting in the dark here. I have no idea. But one thing that I need, right, or would want, is some way of seeing how many unique samples we actually got in that case. So what I could do is say, if we wanted to, we could produce a shader that sort of just tried to count the number of unique samples that we were getting, and draw that somehow. So you can imagine how we might do that, right? If we zeroed out this entire block. And instead of doing that block, we just implemented a little thing that does counting. And again, this is strictly for debug, so it can be absolutely horrific. What I could do is just make it n squared, because why not, right? So I'm going to pick up depth A and depth B. So this will compare, right? It's two loops. It's a loop from 0 to sample count, and then from whatever the current sample we were on to the sample count. I'm going to do +1 because I only want to compare against different samples. And I'm going to do -1 here because obviously I don't need to do the last sample compared with itself. So we'll loop over every single one. And what we'll do is we'll say if depth A is not equal to depth B, we'll do unique count +1. So that will basically give us a counter that says how many there are. we'll say the result color A equals 1, and then the result color R equals result color G equals the result color B. And then what I'll do is just say the result color B, in this case, equals the unique count. And I want to multiply that unique count by something that will boost its value, because it's only going to go between 0 and 8, right? Well, it will at least be... I guess we would say the unique count starts at 1, because even if all the values were the same, we would still want 1, right? If we're actually talking about that value. So if all the values were the same, we'd never increment this. So if there were 2 values in there that were different, we would increment it there. So this is how many pairs there are that are different, right? So it says, is this value, how is it different from all the rest of the values? Is this a different value? I'm trying to think if this is the best way to count this concept. So let's think, if there were 3 different values in here, the problem with that is we'd count how many pairs were different, and it's not how many different values there actually are, right? So I think what we actually probably want to do is break out of that loop as soon as we find one. So if we just loop through and say, okay, if we find a difference, then this color is a unique color, right? There isn't another one, or I should say, it differs from other colors in the buffer. We go to the next one, of course we would still find it. Yeah, this is not doing exactly what I want. Also, we don't want mins in here. So what I really want is something that's more like, okay, I look at this color, well, it's a depth value. I look at this depth value, and I want to make sure that I count this depth value if it's new. But if it already equals something else in the depth buffer, then I don't want to count it. So I think really the correct way to do this would be to sort of do it the other way around, which is to say that if I've seen something in the depth buffer up to this point that is the same as it, don't count it. So I think the correct way to do this would actually be to say, well, the first one's obviously unique. Let's go through it. I should just, yeah, this is a better way to think about it. It's just clearer. So I think this is what we want to do. Something more like this. So we say, okay, for each color, we assume that it's unique. Let me get the false entries out of there. So we'll assume that this color is unique. We take a look at the depth. I'm sorry. We assume this depth sample is unique. We take a look at the depth. We then loop through all of the other depth values we've seen so far, starting at the first one, coming to this one. And we say if they're equal, then this can't be, this is not unique. Right? That's the n squared way to count the unique colors, I think. Right? I think that's proper. So I'm just going to see what happens there. In this case, again, the maximum value, therefore, would be the sample count. So what I want to do here is basically divide by the sample count. And multiply by the maximum color value, right, which is 1. So this here would give us something that gets brighter based on how many unique samples there were. At least that's my assertion. Boolean expression expected. Okay. So here we can sort of see, obviously one thing that we expect to see, which is that, this is happening mostly on the edges, right? Which is what we want because multisampling is only supposed to happen on the edges. So the fact that we're seeing multiple samples on the edges is kind of what we would expect, right? Unfortunately, this doesn't really tell me whether we're seeing 2 at the edges or 1 or whatever. So what I would rather do here, I think, is maybe be a little bit more explicit. So let's go ahead and set result color to 1, but let's take a look at unique count and say something like, if unique count equals 1, then the result color RGB is going to be something like that. And let's just say 2, 3, and greater than or equal to 4, something like that. Right? So if there's 1 sample, we're going to call that uninteresting. If there's 2 samples, we're going to call that green. If there's 3 samples, we're going to call that yellow. And if there's more than 4 or more, we're going to call that red, right? Okay. So, what I'm looking at here is all green. So what that suggests to me is, or what that says to me is that unless I wrote the loop wrong, we are actually getting only only 2 depth samples at those locations, right? Which is an interesting start. Okay, but truth be told, I have absolutely no idea why that would be in a lot of these cases. What I would like to do is find out, is that actually valid for this area right here, for example? So where, these two things, these two triangles, what I want to know is, are there 2 samples along this line because the 2 triangles themselves are abutting and we're getting samples from either of them? Or is it because we're still writing multiple different z values per sample for a single primitive? And what I could do there is just, well, I guess I don't really know any way to figure out what I want to figure out. I say. So if we take a look at what I'm actually looking at here, right? That's anywhere the depth samples vary at all, right? So we're counting how many times we get any variance in the depth samples. So for example, we should be able to prove a couple things about this. So for example, if we came here and said, well, all right, let's suppose that we set the input z to the same value all the time. So the fragment z that we were going to write is just going to be 0.5, and there's nothing you can do about it. So basically, like, the values are just always the same, right? And so what we should see here, right, is we should see that everything is black. And the only possible way you could get non-black is at places where you're going to see through to the literal background. Right, where it was literally just to the background. And that pretty much looks like it here. But it's a little bit hard to tell, right? We probably need to be able to flick between modes here. Which I suppose we could do. So here's some of these crazy parameter things here. I'm not sure, we probably can, if we want to, just put these in the OpenGL renderer, right? So if we wanted to, we could do a thing where we were like, something like this. So in here I could say something like, something like that. And then when we're in here looking at this, when we do resolve multisample, I suppose what I could do is say, well, okay, you know, if multisampling debug, and move this up to the top, so I could just do it as a not. And then in here, we would just say, and I believe we'd always capture those settings, right? It's just current settings. So in theory, that will force a recompile, or it should have, but it doesn't appear to have. I guess one thing is we do have the if changed. So we need this function here. To include it. So remember, right now we're writing arbitrary z values, so our sort is completely busted because it has no information to work with, so it's just kind of order-based at this point. So then if I come in here and I turn on debug, in theory this will actually turn on debug. So that definitely did the recompile, but it doesn't look, it didn't look like it actually did recompile. Although that may be because we do recompile, resolve multisample. Where do the settings do get snapped there, and when I pound find, make sure I actually did this right. When I pound to find multisampling debug, I do actually do that right. So that looks roughly correct. Let's give that a shot. I didn't delete the program. I wonder if that was confusing it. I don't think it would have. So something else appears to be wrong there. But I'm not sure what, right? Like I would have expected that to work. Let me go ahead and see what is actually happening in that compile step. It looks like that compile step is not properly making that switch between the two different kinds. All right, so the first compile multisampling debug is off, but that's exactly what we would expect. Let's take a look here. We turn it back on. So now multisampling debug is 1. The format string, let's just take a look at what it is to make sure that it actually produced the right thing. Oh, not at all, right? That's what I watched. So here we go. It's multisampling debug is 1. Oh, hi, that's good. How about we actually use the actual value I defined. So now we can flip between these, and man, does that compile take a while, or for it to settle down, right? But at least I can see that I can verify that it is what I expected, right? Which is that the only place the fragment values differ is where the background showed through, because obviously that's got a different z value, right? So you could see very clearly that that's what was going on. So I'm relatively satisfied that that's okay. So at least we know that like our counting is working at least to a limited extent correctly, right? Where it's not completely busted. It does work a little bit. So now if I actually set the input z like I was, supposed to be setting it, so doing the actual, taking the actual z bias value and dividing it. So now if I take a look at that and go, okay, now where am I getting the different values from? And I turn on the multisampling debug here. We see that it's happening at all of the primitive edges, which again is roughly what we would expect to have happen. Yeah. So the only question I really have here is, I'm trying to figure out if there's some way that I can verify separately. And I don't know how to do this. But I'm trying to figure out if there's some way I can verify separately that along the edges of a particular primitive, we are getting the same values. So I do think there is something I can do for that. So you'll notice when I'm flat on, all those go away, which is good. So if we look up here, so here's what I'm gonna propose, and I don't know. You can see what you think of this. So if I look up here, what am I looking at with these dashed lines, right? Well, that's the top of the tree which touches the edge of the texture map. So it's the edge, it is on the edge, so when the alpha value is positive, which it is in this case, we're getting multiple samples there. Now, one reason we're getting multiple samples there is because the background is included. But I can take the background out of the equation, right? I can instead say, okay, when we're doing our counting, don't count the background. So inside this loop, when we do depth, the depth A, right? What I can do here is say, all right, if depth B is the background, or depth A is the background, skip it, right? So for coder indentation fighting me. Okay. If depth A is not equal to 1.0 and depth B is not equal to 1.0, right? So basically saying if I take backgrounds out of it and they're still not equal, then we will consider it to be a match. I'm sorry, and they're still equal, then we'll consider it to be a match. If either of them is the background, we're just not going to count it, right? Now, I don't know that I did that comparison correctly. So that is very bizarre. I must have done something wrong there. Oh, right. I guess I want that the other way. If either of them are the background, it's not unique. It's not a unique sample. We don't care about that at all, right? I suppose that's not quite fair, though. Because that doesn't handle the case where we have something unique across the background. So I just need to get rid of any sample that is... No, actually, I guess that's right. I think I am right. Right, so I need to say if either of them equals 1, so if either is the background or they are equal to each other, then this isn't a unique pairing that we're going to care about. Even weirder. So now in theory, I've taken the background out of the equation. And what you can see here is that it did eliminate those tops, right? So what that means is that we're not getting multi-samples when we only have one primitive, right? At least that's what it looks like. So now let's see if that really is because we did the Centroid thing. I'm just trying to verify that that Centroid thing worked. So here's that Centroid bit with the input Z. So I'm going to come here and say, well, all right, we've got the frag Z, frag depth, all this stuff. If I was to just stop, if I was to just stop doing that, right? So I'm not going to use the input Z at all. I'm just going to allow it to do its standard multisampling. So now do I see multiple samples up there? Because I should, right? I'm expecting to. Holy moly. So now everything has multi-samples. And I do still get the ones at the edges. All right. So that, appears to be at least it appears to me that is doing what we wanted. Right? And if that's the case, then I'm not sure why we're not getting the anti-aliasing. So now we have to go figure out if that really was the case. What am I missing here? Because something is going wrong. We don't get any blending when we try it this way. But we should. Because if that primitive edge, like if those primitive edges are writing the same value the whole way, and I guess another way I could do that, right, is I can just focus on this guy right here. So let's take a look. Right? You can see right there, there's absolutely only one sample right there along that edge. And yet, it is pretty clearly not anti-aliased. So if I take a print screen of this guy, right, and I go into Paint and zoom on in there, it's pretty hard to tell. Maybe that is anti-aliased. There's so much blurring in there. It's very odd blurring. You know what? I think that's the stretch blur. That's the blurring from stretching this up. I'm going to have to go into the super slow mode that's 1:1. because the blur at the end is making it so I can't really tell. Let's see here. This is going to be bad for the frame rate. This graphics card cannot handle this at all. Very old graphics card. Cannot handle high resolutions. All right, so let's take a screenshot there. Or at least I tried to take a screenshot there. I don't know if I succeeded. Can you stop doing whatever you're doing? We have more than one version of Visual Studio open. I don't know. We just did. All right, well, doesn't matter. Anyway, so let me go ahead and take a look at that. Hopefully I captured it. Oh, great. It captured it with that thing in the middle. All right, let's try that one more time. I really gotta switch to a machine with a modern graphics card. This is nuts. Trying to develop on this thing. We also have to make our camera interpolation code not be frame rate dependent. You can see it's oscillating. The spring of the camera is oscillating there. So in theory, this is 1-to-1. So let's take a look. And yeah, you can see there's like no blending at all. So unless the counter is broken, we know that there's only one set of depth samples there. So if there's only one depth value across all the samples there. So what that suggests to me, right, is that we should be able to do our primitive thing properly. Oh, and you know what? I just thought of at least one reason why we're not getting the smoothing there. Although this doesn't really help fix the artifacts that we were actually trying to fix. So what I just realized is, so when we take a look at this, we're always going to get that depth range, right? We're going to do that depth. I'm sorry, we're always going to get that minimum depth. Then we're going to sum everything as the minimum depth. We then need to make this be something that composites with other things. So the fact that I was tracking the used sample count is actually wrong. We want it to be darkened based on samples that it doesn't take so that the alpha value gets reduced, right? So what we actually want to do is always use always use the full sample count. Right? Is what we actually want there. Because what I was doing before is saying, well, if we only had 3 samples from this primitive and the rest were for something behind it, well, let's just figure out what the color was of those 3 samples. But that's defeating the whole purpose of the multi-sampling across the edge. What I want to do instead is say I only have 3 samples and there were 8 samples total, so I want to take 3/8 and make that be the resulting color for this thing, right? And so you can sort of see that's now at least doing that operation. but it's not summing up properly. And you can see that because you're getting those bands in there. And that's a little bit more puzzling, because in theory, you know, if you got 3/8 samples on one of them, you should have gotten 5/8 samples on the other one, so they should add up properly, right? But of course, that only is correct if the alpha part is correct. And I suppose that's a part that we're not really dealing with here correctly. Because since we're modifying the alpha value here, right, when the combined color comes in, if we're summing up the alphas, I still think that should probably work correctly, right? Because if we sum everything up, then we square root the color. Because the problem is we're trying to produce pre-multiplied alpha here, and I guess I'm not sure, this is that classic problem of why gamma correction is so awful, is because pre-multiplied alpha and gamma correction just don't work correctly together, really. And you get into the situation where, like, okay, so in this case, right, I've got a combined color value that I'm loading out pre-multiplied alpha from texture maps and such, and when I get those values back, I'm summing all of them up. And so the question is, at the end, I'm going to have a different alpha value than what I started with for any individual sample. How do I reproduce the correct pre-multiplied value that would have been what those were if they had been summed up just as regular colors and then mapped back? And I'm not sure. Like in this case, the inv sample count thing, right, is going to reduce the total alpha, whatever it is, and the colors. You know, should that just work? I can't quite tell. I mean, I guess I can experiment with it a little bit. I could say something like, well, when you load the color value, go ahead and unpre-multiply the alpha. You know, that would look something like that. And then when you're done, so when you produce the average value, do it back. Doesn't really seem to change the results though. Although, you know what, I just, are we still, did I accidentally still do, before I go down that road, did I forget to turn off the, no, so that's still on. So I don't know. I'm not sure why we're getting that. I'm going to switch back here to a lower resolution. really just do not know where that's coming from. So two things. One, it would be nice to fix this and then see if we could get any more improvement on what we were doing. However, I would point out that even if we do, we still end up in the same sort of problematic position where we would have two depth peels executing across the seam, right, across the two triangle seam. So I do also wonder here whether this isn't just an absolutely impossible task that we're trying to do here, right? You know, maybe if you're doing depth peeling, the only way you can really smooth things is by oversampling, and that's what you should do. I don't know. I really don't. Because obviously, you know, when we turn off multisampling, all of our artifacts are gone. And so we have a really nice renderer in that case. And so all we want to do is smooth those edges. I wonder if the correct thing to do is just to draw at a higher resolution and downsample it, right? And it gets rid of all that complexity. I mean, we could try it, right? I think all we have to do turn off multisampling and then ask for a high resolution. Right, there's 2x oversampling. It's a box filter, so it's not going to be great, but you know, we'll see. What does it look like, right? So let me go ahead and take a shift print screen of that. And there you can see some of that, right? Sampling going on there. It's not great smoothing. I'll be honest, it's kind of somewhat nonsensical smoothing even. I don't know how it's producing those values. Those don't even look like proper box filtered values to me. That looks a little bit wrong. I would be lying if I said that that looked at all correct. How do you zoom back out? There we go. Because if you look at this line, what you should see here is even stepping. You know, this should be the same range of color values as you go down. And what you're seeing instead, and I can zoom right in on an obvious case right here, is 1 pixel of one color, 1 pixel of another color, and then the same color the whole way down. I guess I could convince myself that that was just because that's the corner. So maybe that's correct. Because, you know, you've got right here to right here, if you imagine what that looked like beforehand, there was an extra line in the middle. And so you're getting half the value. Yeah, okay, yeah, that is, I guess that is correct. Never mind. So that would be with 2x oversampling. Let's try 3x. Again, this is going to get really slow. This graphics card is not really good enough for what we're doing here. And now that I think about it, that's not going to help, is it? Because when we do our downsampling, once you get it's not going to do a wide enough filter. We would have to implement our own sort of process of sampling it down twice. So the only thing we really can do is 2x, because that the bilinear filter will do. Yeah, which is not great. So if we wanted to try the oversampling approach, we'd have to do something a little bit more clever. And so in here where we're doing our let's take a look here. So in here where we're kind of doing our final operation, this is the part after the depth peel is done, so it does all of the depth peeling there. We would need to make this final stretch be something that's sort of operating in a loop. So we'd have to, you know, well, it wouldn't really have to operate in a loop. We could just make a single sampler that takes lots of texture samples. So it knows that it does a downsample by a certain amount. And so, you know, rather than just doing bilinear filtering, it could take significantly more samples if it wanted to. It could take 16 samples, right? It could take 16 bilinear samples even if it wanted to. So we could make it take a lot more samples if we wanted to, and then we could render at a higher resolution. Unfortunately, yeah, on this card, it's just going to be way too slow. What we could do, however, is run at a lower resolution, and like, for example, you know, if we still just ran at 1920 by 1080, right, and then downsampled to a much lower resolution, that would work. At speed on this card. And then people with a higher end graphics card obviously can just run at 1920 by 1080 and would be oversampling at like 4K or something like this. Yeah, so I really just don't know. I guess we have one more thing we could try tomorrow, and that is a little confusing. But we could try to figure out some way to make it work. Which is, we could try to do something where we have the depth peel buffers actually work in multi-sampling mode, which maybe is something that could happen. I'm not really sure how that would work. So I don't know. All right, so we've tried some things. We've seen you know, a couple different results, but we don't really have a good answer yet. I guess I'll go to the Q&A for now. And we will see. We will see. I don't know what the best approach would be. Let's see. Debutsuki says, I can't compile the code. It's saying pastebin. What is pastebin? Okay. But not having support for this makes no sense because I have an R9 390, which is a newer card than you. Have you tried what we did in today's stream, which is setting the version number to pound 150 instead of pound 130? Have you done that yet? I did that on today's stream. I don't know if you caught that. Frosty Ninja, I haven't really followed along with how you've implemented peeling, but what if you separate out 3D objects and run them through a different shader that doesn't do peeling? Well, we need the 3D objects to go through the peeling, is the only thing. Would doing a depth prepass without multi-sampling help? I don't think so, because that's no different than just doing the multi-sampling and then during the resolve picking one depth value, because that's the depth prepass would be picking one depth value, right? It would be picking the closest depth value. So as far as I know, doing a depth prepass without multi-sampling is the same as what we're doing now with picking depth min, right? Flying Solomon, what do you think about FFmpeg? FFmpeg, the video compression thing? In your opinion, is there a better way to implement a video-oriented program? Sorry, that does not sound like a question for me. It sounds like a question for somebody who does video stuff. Cuber Caleb, if you want the same depth for each multi-sample, couldn't you write the depth as a separate vertex shader output with centroid interpolation? That is what we did. Right? That's exactly what we did. That's this right here. And it worked. So we can actually get that. The problem, at least from what I saw, was that if I went to then use that information, I still end up in a circumstance where when two primitives abut each other, they're going to have different Z samples across that scene. And I don't know really any way to resolve that, right? Like, there's nothing I can do about that particular thing. So it seems like kind of like almost to the point where we got something, but I can't I can't really figure out how I would get any further along that line yet. So here's what's running currently, right? And so in this case, you can kind of see well, you can see the situation right here, where like, hey, all around the edges now, we don't get multiple depth samples. So that centroid sampling worked great. Unfortunately, at the seam between two triangles, you do get multiple samples, and that's not fixable in any way that I can think of, right? What do you think about FFmpeg analyzing? Did that one? Or depth sample each sample? If you want the same, we did the Centroid one. It works. Is that the version? Okay. So this is D Mitsuki asking a follow-up question. Okay, good. I'm glad changing to pound 150 works. And yes, that's the version of the sampling language you're trying to use. So which version of GLSL is the pound? When you put version pound something at the top of a shader, that's saying this is the version of the sampling of the shader language I want to use. And although this graphics card's driver, which is an older ATI, very old, it's a decade old at this point or whatever, it allows you to use Sampler 2D MS in the actual shader in version 1.3.0. It's not supposed to. So what happened was we had the version at 1.3.0 and then started using Sampler 2D MS. It just let us. It's not supposed to. So if your card probably has a more compliant driver, which errors out in that case. So changing it to 1.5.0 is correct because that's the shading language version that actually includes Sampler 2D MS without extensions. Surge RGB. Oh, it's Sergio. Hey, Casey, sorry about the cursor bug. Could you try creating a new canvas to see if it still happens? I missed the start of the stream, but people told me that it only happens with Wacom input. Is that true? Yeah, actually, it does appear to be true. So, let me show you. So here's the mouse. I'm just drawing with the mouse right now. And you can see that it's totally in the correct position, right? If I draw with the cursor, it's, with the Wacom, it's offset. So I can try creating a new canvas, but it doesn't seem like it has anything to do with the canvas because it's just the difference between mouse and, there's just a bug between mouse and Wacom tablet. So the Wacom tablet mapping is wrong to where it thinks the cursor is. What I think is happening there probably is that the Wacom tablet has a higher resolution than the screen in the mode that it even showed that when we went to the Wacom thing. When we first popped over here, it showed this thing was like the whole area, right? Know how to get that to happen again. So I don't really know how to make that happen again to what it was, but hopefully if you went on the well, yeah, I guess. And of course the fact that it's not doing it now, I don't really know. Yeah, I'm sorry. I wish I could give more information about this because the new version feels really awesome, actually. So I would really love to get it working properly. And that seems to be the only thing here. And I don't remember it being, it didn't seem to fix it when we did do a new canvas when we first tested it. I don't remember that having anything to do with it. But yeah, the drawing feels really snappy now. So I feel like there's just something wrong with the mapping, and everything else is pretty great, actually. This is also happening. I don't know if you can see this on the stream, but when you scroll around, it jumps weirdly. And it kind of feels like that might be the same kind of bug, because that offset, again, is like maybe fighting. It's like using two different offsets, right? It looks like the exact same bug, almost. It's offset by a similar amount, right? And the other thing I would point out is the offset changes. So up here, the offset is very close. So it's correct at the upper corner and gets less correct as you get further down, right? So it's as if it's taking this region of the cursor and mapping it to the whole screen. So it's definitely just like a scale. It's like some kind of a rectangular scale problem, like the Wacom tablet is giving you back something that's in a different coordinate space, and somewhere it's also probably giving you back some scaling factor or rectangular remapping that you have to apply, I guess, right? And that's not getting applied properly. But I have no idea, since I don't know very much about the Wacom drivers, I have no idea where that data would be or what the likely culprit is. But something like that is happening. Nucles, hi Casey, do you have a few more good scientific programming papers to get me started on a good habit of reading long stuff for coding? I do remember those from papers I loved and the rasterization bridge one. Maybe there are some lighter reads to begin with. So I'm not sure. Here's one that I might recommend. And this will be relevant to Handmade Hero, because when we do a real random number generator, we will care about this. So one thing is that I think this paper is probably an accessible one. Sometimes it's hard to know how accessible something is. I guess when I read it originally, I wasn't necessarily looking at that exactly, but this is Melissa O'Neill's paper on permuted congruential generators. I think that's what that stands for. I always forget the snappy acronyms these days. That is what they're called, right? Permuted. Where is it? Well, anyway, it's her paper on taking like linear congruential generators and other sorts of like low quality random number generators and turning them into really high quality random number generators with very easy operations. And it's a pretty great paper because it's like a very good way to generate random numbers for games, because it's extremely fast and it's very, very random, for lack of a better term, compared to other things. So, we'd be doing this on Handmade Hero eventually for our random number generator. I feel like this paper, because it's fairly long, it's 46-page paper, she took the time to actually describe everything in accessible terms. She doesn't slam you with a bunch of equations and then just let you figure it out. Like, she's got a lot of text in here that's just like, let me explain to you what I'm talking about, which is great. And so I feel like this would be a pretty good paper. It's a pretty obvious topic for most people. Like, random number generation is very easy to understand the concept of at a base level, right? And all of the stuff she's doing, she explains in pretty good, like, basic English descriptions before giving you anything specifically mathematical about it, and includes plenty of diagrams and that sort of stuff. It also, like I said, happens to be a great paper. Like, just the actual technique happens to be great. So I feel like this would probably be a good one to look at. That'd just be my guess. And it's got code in it, right? Which is another nice thing if you're trying to be more accessible. She's just like, here's the actual piece of code I'm talking about, right? Instead of like obfuscating it behind a bunch of equations, which she could have done, right? And she has equations in here, and she could have left it at that, but she doesn't, right? So I would say that might be a good one to start with. Like I said, it's long and detailed, so if you're willing to put the time in, it's explained very meticulously. There's not a lot of hand waving or go figure this out yourself from these equations. It actually says what it says. It's a really good technique, so it's an interesting thing to read about and useful. And it is about a topic that you should be already familiar with, so you're not coming in cold. So I would say maybe that's a really good one to start with. I don't know. Oh, and again, I guess I should... Well, you saw how you search for it. Type in PCG space O'Neill, and you'll get, her homepage or the paper or both on the front page of the Google hits. So that it's easy to find that paper. How's 1935 coming? Long time no news. We're still just not quite ready to release press stuff yet. We've been working on it, but it takes a long time when you only have one programmer. For a very ambitious project like this, so we're hoping to have stuff up pretty soon, but it's still a little bit off. So shouldn't be too long, I guess is what I'd say. We probably will release some screenshots first, is what I'm guessing, but we'll see. If thread behavior is considered to be completely random, can we leverage it to our random number generator? Thread behavior is not completely random. I don't really feel like that is a reasonable thing to say. I think thread behavior goes through lots of different permutations of the order in which things can happen, but I really don't find it random necessarily. At the bottom line, Windows Scheduler happens on regular interval updates, so I just don't know that that's a good source of entropy. If you're looking for a source of entropy for non-cryptographic purposes, there's one built into your processor. So, that's going to be easily as good as thread behavior. Remember the... oops, that's not what we want there. I don't remember the mnemonic for it. RD-rand, that's what it is. So, you know, if you really want some kind of hardware randomness, RD-rand is probably what you want. It's basically like a, you know, nominally cryptographically secure random seed you could use. Unfortunately, it's probably not cryptographically secure. Like there's probably like, you know, the NSA backdoor in it or whatever. But we don't care about that in a game, right? We don't care if the NSA can predict what the random, you know, we don't care if the NSA is really good at Binding of Isaac because they can now predict, like, you know, which item drops you're going to get. So, you know, if you really just wanted hardware, you could do it this way. And that's probably a lot more sane than trying to use some kind of thread behavior to do it, which I think you'd run into a lot of problems with because it's not so random. Cuberkillab, isn't PCG less favorable than something like XOR shift for games because the stepping function can't be SSE optimized? Well, like I said, it depends on exactly what you're doing with it, but PCG and XOR shift, PCG is just an additional step on XOR shift, right? So if you just build your game with XOR shift and you have parts where you want to have better random numbers, right? Which I would argue world gen is. You know, particles maybe we don't care, and XOR shift is fine or whatever, right? But if you have a situation where you want to do like world generation, like, you know, when you're actually doing the roguelike parts of your game, you want those random numbers to be higher quality, and I doubt you care how SSE optimizable they are, right? So if you find that XOR shift with the permutation step, which is what PCG is, right? PCG is just XOR shift to the permutation step. If you find that for some reason the permutation step is too hard for you to optimize, then, you know, you can just not do that in the few cases in the game where you're really performance bottlenecking on your random number generator. But the world generation part of your code is probably not that, right? What I don't know is, having not tried to do an SSE optimized version of PCG, where is that permutation step? Sorry, I don't really remember where in this paper the XOR shift plus modulation step is. I think I already passed it, unfortunately. No, here, it's right here. So I guess the first thing I would ask is, what is the inefficient part of this as far as SSE is concerned? Is it because it's a variable? Is it because it's a shift? I guess the problem is that you can't, in like SSE2, you need the shift to be in immediate. It has to be a fixed value. Is that the part that you're concerned about? The 64-bit add, I don't know how hard that part would be. I don't know. Did you look at the 32-bit? I thought there was a 32-bit state one as well. Or maybe there's only 64. So here's the thing, she doesn't list the 32-bit one here. But the 32-bit output and state one would not have a 32-bit state vector. So it would only be the variable length shift that would be the problem. But I do agree that the variable length shift is a problem. Since it took Intel forever to add that in. Let's see. Tag. How come there are different Z values on the diagonal on the same sprite? Is it an epsilon issue or did I miss something? It's not an epsilon issue. That's just correct, right? And that's why it's a problem. That's why I was saying that's a problem. I'm not sure how you get around it because it's not a bug or a weird like floating point inconsistency. It's just correct. When you have multiple samples from a sprite whose Z value is changing, along the diagonal, the only reason we're not getting different Z values per sample inside the interior of the sprite is because we did that centroid to force them all to be the same. But otherwise they would vary because that sprite, remember, has different Z values. As it gets taller, as it goes upward, it gets higher and higher Z values, closer and closer Z values. Those actually be lower Z values, but yeah. So the problem is multisampling kicks in when you're on the edge of a primitive. And of course that diagonal is the edge of a primitive. It's the edges of the two triangles. And since each triangle is covering different samples, the actual sample value there is just one of the samples, right? And if they don't both pick the same sample, then they're going to pick different Z values, right? And I don't know that you can ever force, like, I don't know that there's any kind of graphics card magic to force it to do something other than that. You would need something that forces it to pick sample 0 and always use sample 0's location, which maybe you could do somehow. I don't know. But it's a problem. So we'll have to think a little bit about what we want our solution to be to that, or just move on and leave it, because we now know that like our non-multisampled version is what we want. So we could just move on and say, look, we'll leave it to the saucy graphics gentlemen to tell us someday what the right way is to integrate multisampling into this pipeline, or not necessarily multisampling, but some sort of edge smoothing. And we'll just punt for now, because it's not going to affect the rest of the game. It's an option, right? It's an optional thing you turn on. And so we can just make that be something that we punt for later. All right, so I'm gonna wrap it up. We're already a bit over time here. All right. So let me close this up. Thank you for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can play around with it at home. We also have a forum site you can go to if you want to ask questions, a Patreon page, if you want to support the video series, a schedule bot that tweets the schedule at you, so you know we're going to be live, and an episode guide where you can find past episodes with a great annotation search feature right now too that has recently been added. That's awesome. So that's a great place to go check for more information. That's it for today. I'll be back here tomorrow at 12, so noon Pacific Daylight Time. Hope to see everyone back here for that. We'll either decide to punt the multi-sampling for now, or if I happen to have some other idea I want to try, we'll try that idea. So we'll either move on or we'll try some other idea. We'll see what happens. But otherwise, pretty happy with the renderer. The depth billing part works great. So it's really just that polygon edge smoothing is about the only thing that I think we really have to worry about at all. All right, so hope to see everyone back here tomorrow. Till then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.